Okay, this video is going to pick up right after where the last one left off. I'd just been doing a little bit of machining on there last night, but the mosquitoes were starting to get me, and it was a bit dark and it's a bit awkward to work in here without good lighting, so I thought I'd wait until today to do some more. So what I hadn't showed you before I started doing that machining is that I had to do a lot of tightening up and adding of more bolts into here, because I went to put the spindle on and I'd been doing the tests with the pen, you know, drawing the tiger, and it seemed okay. But when I went to put the spindle on, I was just sort of going like this with it, and it was all rattling around in here, and I realized that some of these bolts weren't even like fully tightened. They were just sort of put there to get things in the right place and check dimensions. So I had to basically disassemble this whole front piece and put all the bolts in, well, not all of them, but as much as I could get in that seemed reasonable, and tighten them up properly. And along the way I discovered that getting this off and on is kind of a nuisance, so in my new design for these middle plates here, I'm going to add a holder for limit switch inductive position sensor thing there, and I'm also going to add some more holes so that these bolts here, see, like that one there is going through both of these two plates into the back there. But what that means is you can't put that bolt in until you've put the whole front piece of the Z plate on, which is kind of a nuisance. So my new design is going to make it so that it's a little bit more easy to assemble in two separate sections. So that's the holder for the limit switch. It hasn't really changed that much, but it will make things a lot easier to assemble. And also I'm going to need some holes here so that those are so that the Y nut block in the back there can be accessed from right from the front. Like even from right now I could access it, as long as this is up in the right sort of vertical position. So it's going to make it very much more easy to assemble the back part of this and the front part of this completely separately. And it's kind of necessary to assemble this, or it's dangerous if you want to fiddle around taking this on and off vertically like that, because the balls have a pretty good chance of falling out. But if you can take this off, lay it down flat, it's much easier to work on. And then when it's all assembled, you can just pick it up in one piece and you don't have any risk of anything slipping out, because the ball nut on the inside there now stops this plate from sliding off each side. Anyway, so what I'm going to be doing today eventually is I'm going to be making this, or actually that, from aluminium, and also the front plate. This is the back plate. But what I'm going to do first is make it out of MDF, just to customize myself to Linux CNC and editing. I'm doing quite a bit of editing G-code manually at the moment. Eventually I think that will be done in a post-processor from FreeCAD, so I won't have to do that. But it's good to know how it's done. And my system at the moment works by, oops, where are we? So I'll work on my computer inside. That's that one there, 101, and then I'll just put it on my web server on that computer, so that I don't need to bring any flash drives, you know, USB sticks out here all the time. And then I can just get the files from there. And I've been fiddling around this little bit at the beginning there. I'm adding that manually, the M3 and the G4, so that's to start the spindle and then wait, in this case 8 seconds, for it to speed up. And the rest of it there is all coming from FreeCAD. I'm doing a little bit of modifying of the feed speeds in here, just by search and replacing that. It's a little bit easier to do that here than it is to go back to my main computer and change it and then get the file over here again. But anyway, that's how things are working out. So I'm just going to run this at what is probably the fastest speed that can be done. Or I was watching a video by a guy called Winston Moy, who does a lot of videos about CNC machining, and he was using certain numbers for MDF machining. So that's what I'm going to try here. It's 2 meters per minute feed speed, which seems awfully fast, but if you consider that MDF really is quite soft, I mean, didn't even really have to try hard to do that. So yeah, I guess at 18,000 RPM and 2 meters per minute might be okay. So let's give it a try. fine. Okay, so that seemed to work just fine, and I noticed that at the faster speed the dust that it makes is far less obnoxious, because when I was surfacing this bit yesterday I was doing it about quarter that speed, 600 millimeters per minute, and the dust was so fine. And I noticed a little bit on here too. You can see I vacuumed most of it away, but it was all way up there and probably getting into there a bit too, which is not good. But what I'm going to try doing now is something that I was a little bit worried about with my power system all coming from one plug. So everything I'm powering here is coming through that and going up to that switchboard. So I was a little bit worried about adding more power, because these things, vacuum cleaners, can suck quite a bit of power. But I do want to try vacuuming the dust as it's running to just keep it down. And one thing about this vacuum cleaner which is quite nice is it has this speed dial which you can turn way down. So if all you're doing is gathering dust that's already kind of flying around, you can just turn it all the way to the bottom, and presumably it's not going to use as much power as if you're vacuuming the floor normally. Okay, well that was quite quick and painless. The 2 meters per minute actually didn't seem all that fast. Actually, it probably could have gone a little bit quicker. It was so quick that when I discovered that it hadn't cut through along this bottom half here, I just dropped the Z height down by 0.5 millimeter and let the whole thing run again. And it wasn't even a problem to wait for it. It didn't take long at all. We do have a problem though, and I think this might be a problem in Linux CNC. See this bit in the middle? That's supposed to be a proper rectangle, but for some reason it's shortcutting on the corners. Well, one corner it did properly, but that's only because that's where it went in. It has a little bit of a ramping thing there, so that ended up okay, and it ramped in this one as well here. But all the other ones there, like that one, these two here, it's decided it's going to take a shortcut through there. So this is the bit that came out of it. Not supposed to be like that at all. And the reason I say it might be a problem in Linux CNC is because, so the white lines is where the G-code says the tool should go, and the red lines is where the tool went. So Linux CNC knows both of those, and it can also tell us that they're not the same. So I wonder why they decided to do that. That's very strange. Okay, I managed to figure that out. It seems that by default Linux CNC is allowed to take liberties with it's allowed to prioritize acceleration limits over actually following the path that you told it to follow, which seems extremely bizarre, but that's the way it is. And fortunately it's quite an easy fix. You just put a G61 at the beginning of your program like that to tell it not to do that. And I think the reason why some of those were allowed to have the corners cut and some of them weren't, I was puzzled about why it seemed to know which ones would be a problem for the shape. So it's only the ones where it didn't matter that it's taken that shortcut like that. See, if it had have taken a shortcut on this corner here, that would have been a problem. Actually it wouldn't, but it could have been. And I just noticed that maybe the difference here is that some of these corners are already rounded like that in the program, so the G-code has a curve there for that one. But this one over here is a square corner. So it seemed to be only those square corner ones that was having that problem. It's kind of ironic that the square corner one ended up with a much larger radius than the one that it was told to be a small radius. I just started cutting out the front plate there, and this one has an adaptive clearing section to begin with, and I was having huge problems with the X motor stuttering and like jumping, and like it wasn't really it was just sort of moving like that, and I thought, what the hell is going on? It took me quite a while before I realized that it's this G61 command that I put there, and what that does is it allows it to almost stop completely anytime there's a sort of a change in curve or something, I think it is, and that's basically what we've got here for this adaptive clearing the whole way around. So I think what I'm going to have to do is use this G61 selectively only on some parts, so when I'm doing this sort of adaptive clearing I'll leave it out, I think is what's going to have to be done. Well, I managed to get both of these pieces machined, and they match up very nicely with each other, but I was so preoccupied with that the curving issue and the G61 and the G64 that it wasn't until afterwards that I noticed that the axes are not even square to each other, so you can see that pocket in the middle. It just at a glance, it's not even remotely square. So I'm just doing a little bit of adjusting of the well, the x-axis actually is quite easy to do this, because all I need to do is loosen the grub screw in one of these here so that the belt will turn but the ball screw will not turn, and then use the keyboard to jog a little bit until I can get it square, and then tighten up that grub screw again, and everything is pretty good. What I've done here is I just machined an edge here so that this edge is in line with the x-axis, and then I was putting the very tip of the blade there right on the edge of the straight edge or the square, and just running it all the way down to here, staying the same in X, and adjusting until it sat right on the tip of the square there. So that's about all I'm going to do for now. I'll have to spend a lot more time doing this more properly when I put the real machine together, but let's just see what that does. Oops, had to get my camera out of the way of this bit here, but you can see it's right on the corner of the straight edge there as well. So now I'm going to have to make those MDF pieces again. I could probably just jump to making the aluminium ones right away now, after having squared that and checked the holes and everything. But I think what I'll do is I'll take the time to make the two MDF bits and actually use them first, because part of the reason for making those in the first place was to improve the constructability, or lessen the annoyance as you're taking this apart and putting it back together again. So I should at least do that once to make sure that everything's okay. And another thing that's different is that this piece here was 10 millimeters in my MDF, and it's 12 millimeters in the aluminium. So this 2 millimeter gap there is actually going to be filled, and it's going to be completely touching onto there. So there's a few slight differences like that I should really check before I jump into making the aluminium pieces. Oh, actually I don't have enough 6mm MDF left to make two of these, so I'm just going to jump straight into making the aluminium, I think. It's kind of funny that I have so much aluminium stock there now that instead of worrying about using up my stock, I'm actually worrying about jigsaw blades and end mills instead. Well, that job was going quite nicely for a while. In fact, look at these holes here. The walls of these holes are really nice, aren't they? Yeah, so it got around doing all the holes, and they were all finished. And then we struck a bit of a problem when we did this bit in the middle here, and it started to make a slightly not chattering, but a little bit not so nice noise. And I thought, well, you know, that's to be expected because the machine is not really that tight. So when it got to this bit here, it made an even stranger noise. And at first I didn't react, but I think what happened is it's overheated, and I let it go along this bit here. You can see it's all looks almost crystalline there. So it pushed through that somehow, And unfortunately I wasn't wearing my old man glasses. I can't see things up close very well these days. Fortunately I can see very well in the distance, but I couldn't quite see what was happening here, but it looked like it was pushing that ahead of it, and then it went round the corner, and not even sure what the hell's going on there, but it's a real mess. Well, I managed to jog the Z-axis up. It was quite stuck, but it kept going and then suddenly popped out. So it looks like we've got a decent amount of power on the motor and everything. And now it looks like tin foil, doesn't it, the way it's wrapped around there. Okay, I managed to get that off. It wasn't too hard actually. Fortunately, it didn't seem to really stick chemically, or what do you call it? Yeah, chemically, I guess. It didn't stick to the end mill. It was just mechanically really jammed in there. But yeah, came out alright. Over here you can see the aftermath of that. This is all, looks like it was sort of a liquid at one point, but it's very much re-solidified there. Okay, managed to get through that without any further excitement. I changed the spindle speed from 18,000 to 12,000 and the feed rate to about 85% of what it was, which was 200 millimeters per minute, so I guess that's 170 millimeters per minute. And it did, I could see it, I could hear it actually galling up a little bit every now and then, but almost as soon as it did, it would free itself. But I was ready to stop the job anyway, but I didn't have to. And then of course it didn't quite cut all the way through, as is usually what happens, but it's pretty close. And after all that, we ended up with some pretty good finish somehow on the sides there. I think I can pull that off. And yeah, it's could be worse. Some bits there's a funny bump like that there. Not sure how that happened. It's like it's gone in a little bit deeper just for a while and then it came out again. But the rest of it looks pretty good actually. Bit ripply here, I'm not sure what that is. But anyway, I'm not really needing to be fussing about this kind of finish at the moment. I'm just kind of glad that we got this cut at all now. Okay, eventually managed to get that done, and seems like we've got a pretty good result actually. The cutter managed to pull through. I ordered a couple more of these, but this one is still extremely sharp, so that's good because I don't have another one right here at the moment. But anyway, I did some measurements on this, and just measuring from here, the corner there, down to there, and across to there, is about a 1/2 millimeter off the diagonal difference. So it's not perfect, but I think it's going to be good enough to use. And I was quite surprised to see the finish on the edge is really nice. At least the parts where it didn't gall up. So all the way around here is pretty good. And these curves look nice all the way through there. Over here we have that's where one of the screw holes were, or the holes that was already drilled in the plate. I couldn't quite avoid that. I was trying to like miss it with the edge there, but it didn't work. And then there's just a few edges where, like that there, you can see that's where it was galling up and getting stuck that time. But I'm pretty sure this plate should be perfectly usable. Now I've got to clean this off, I suppose. just going to pause it there for a bit because it was, maybe you can see that it's starting to peel up a little bit on the side there, and it was making a noise that was not quite normal, and that's the telltale sign that the tool piece is getting too hot, I think. So we made it through the first 2 millimeters, and hopefully if I just let it cool a bit like I am doing now, I can't stop the spindle unfortunately, but it should be cooler now than if it was running. So just give it a little bit of time like that and see what happens. Yeah. Oh, that was great. It's just that one bit there where it kind of got a bit bumpy. I think I know what's going on now. It's the chips. The chips get in the way, and it's recutting the chips. That's what causes it. Even just a tiny, like one chip getting in the way seems to give it problems. So as long as I'm really vigilant with where I'm holding the vacuum cleaner, it seems to be okay. You can see that after the problem in the middle there, I was angling the vacuum cleaner a little bit differently on each corner, and that really helped. So yeah, vacuum cleaner is not really what you want, is it? You want air blast to be like blasting the chips out of the way, because the vacuum sort of pulls them in unpredictable ways, and even with the vacuum you end up with a little, like a pocket of still air somehow, that like especially in the corners when it was doing the when it comes around here and it was doing that little bit like that, like that. Up in the top here, there were chips getting stuck, and yeah, that was causing problems too on this corner. Anyway, so we've got, yeah, a bit of a ripple. Ooh. Oh no, it's not sharp. Yeah, a bit of a ripple there on that side again. This bit feels good. But I think overall that's a result we can be proud of with just a just MDF frame. Okay, just finished machining this one, and once again turned out pretty nice. I didn't have any mishaps this time, knowing now a few more things about it, and once again the edge finish turned out to be really quite surprisingly good. That shiny and smooth all the way around to there. Just a couple of problems. One is that the my program didn't really clip out that little corner bit right there, so I'll have to file that out. It's just got a little bit of a curve there instead. And the other problem is that this happened with the first plate too, but all of the holes are just not quite big enough. Like that screw goes in all the way, like, well, not all the way, but like I can get the tip of the screw through like that, but then it just doesn't go any more. So I had to run a drill through all these holes just quickly on the other one to get it to do that. But other than that, everything seems pretty good. I was just test fitting these two plates together, and they go together one way, the same way that they were cut in the same orientation on the machine, and I still couldn't get the bolts to go in very nicely, so I actually had to drill through both plates at the same time to take off just a tiny little bit more of the side of the hole. Now they all fit in there nicely, at least this way, and you can see the corners matching up there. But if I try and take one of them, in theory I should be able to take one of them and tip it upside down, and all those holes should still line up. But let me show you what happens when I try that. So I swapped the bottom plate and I've pinned it with just 2 bolts here so that they can't move relative to each other. And that's about the only 2 bolts I can get through, because if we look down the bottom here, you see the corner is now like almost 3 millimeters off. Can you see that? Yep, there we go. Over here it's off like that. And basically these holes are like 100 miles away from each other now. So it's just completely useless if you try and put them together like that. So I'm starting to think maybe I need to spend a whole lot more time straightening up this machine before I can use it to make stuff at all. Although if I put them back how they were just before, maybe I could kind of use it, but the problem is that everything that I make with that is going to be a little bit crooked now, so I'll have to think about what I'm going to do now. And I think the problem, of course, is the Mickey Mouse way that I've got everything set up here. It's just not really done properly. See, these, I still don't have these bolted down properly. They're just clamped like that at each end. Another one holding holding that bit on there. And the other problem is that every so often I notice that, like, I just looking at this before, I've tightened it now, but it was really loose. And the problem is that these nuts had sort of become loose. It's just because the MDF is soft and it just doesn't really hold. And every now and then I check these and they need to be tightened just ever so slightly as well. So the more I use the machine as it's running, it's just kind of falling apart as well. So I'm starting to think maybe I should, it's tricky to know what to do but I think maybe I should just try and replace the base plate with the actual aluminium one. Try and get these rails set up a bit nicer so that I can at least have one axis that's working properly. Not sure what I'll do for next steps after that, because I want to kind of, as soon as I start taking this apart, I can't do any of this kind of machining, and I do want to machine a little bit of stuff like over here. There's a I'd like to make a pocket in here and a pocket down there that match, but